So what do all of these items have in common? Headphones, furnace, clothes dryers, dishwasher valves, power supplies, DVD spinners. Well, they all use magnets. So what is magnetism? What is it that makes all these things that we use work? Well, magnetism is the attraction or repulsion of one magnet to another. How do these magnetic poles interact? Well, any magnets, no matter what its shape, has two ends, each called a magnetic pole. Magnetic pole is the area of a magnet where the magnetic effect is the strongest. The opposite poles of a magnet are labeled the North Pole and the South Pole. Magnetic poles that are alike repel each other, and magnetic poles that are unlike attract each other. Here are some examples of magnets. Say horseshoe magnet, it has a north and a south pole, and regular bar magnets have north and south poles as well. And if you cut a magnet in half, you are not left with just a north and a south pole, you just end up with a smaller magnet with a north and a south pole.
Magnets with opposite poles attract. Objects with similar or like poles repel.
So what is the shape of magnetic lines of force? Well, there are magnetic forces all around the magnet, and the magnetic field is the region of magnetic force around a magnet. Magnetic field lines map out the magnetic field around a magnet, and the lines form complete loops from pole to pole and never cross. So in this picture you can see that they come out from the ends where it's the strongest, and they never cross. They just extend out into the area around the magnet. So the magnetic field of two or more magnets can overlap. We can see two opposite poles, a north and a south, connect together here, and over here two like poles, a north and a north, are repelling with the lines not crossing.
These are the ends of two bar magnets. Right now they're going to attract. Let's see what the magnetic field lines look like around two bar magnets that are attracting. I want to sprinkle some iron filings around it and see if we can see the magnetic field lines. There we go, you can see them.
So what is it that makes something magnetic? Well, this magnetism depends on the properties of the structures of the atoms. The spinning and orbiting motion of the electrons make each atom a tiny magnet. And remember that all matter is made up of atoms, and atoms contains protons, neutrons, and electrons. So it's the number of electrons that will determine, along with the rest of its structure, whether it's magnetic or not, or it's able to be a magnet. Now we have these magnetic domains that are a cluster of billions of atoms that all have magnetic fields lined up in the same way. In a magnetized material, all or most of the domains are arranged in the same direction. So which of these do you think is the magnetic material? One on the left, not magnetized. One on the right, magnetized. Now ferromagnetic materials like iron, nickel, and cobalt have strong magnetic effects because we form magnetic domains, and it's no mistake that if you find iron, nickel, and cobalt on the periodic table, guess what? Neighbors next to each other. And we can make something a magnet that's ferromagnetic by using a permanent magnet. And if we can get all those domains in the object to go the same direction, we can give it some magnetism. We can do this by running a magnet along like a nail or a paper clip. So Earth is a magnet, believe it or not, a really big one. And we know this because a compass is a device with a magnetized needle that can spin freely, and it will always point to magnetic north. The Earth has a large magnetic field, just as there is a magnetic field around the bar magnet. And this is caused by the churning inside the Earth of the molten iron. It's called a magnetic dynamo. And Earth's magnetic field extends into space. And this is a good thing because the solar wind is a stream of these electrically charged particles flowing at high speeds from the sun, and this will hit the magnetic field, and the magnetic field, the magnetosphere, will prevent those streaming electrically charged particles from hitting the Earth and killing us. This is a picture showing Earth's magnetic field extending out into space. Notice how similar it looks to the magnetic field lines that we saw around a bar magnet. So how is it that magnetism also produces electricity? And this is what scientists call electromagnetism. And when electrons flow through a wire, they create an electric current. And that electric current produces a magnetic field. The direction of current will determine the direction of the magnetic field. We can use this to make an electromagnet. And this is a ferromagnetic material that's inside a current-carrying coil of wire. And this produces a temporary but extremely strong magnetic field, which can be turned on and off. And the strength of that electromagnet can be increased by increasing the current in the wire, increasing the number of loops around the wire, and decreasing the space between the loops of the wire, getting them closer together, or using a stronger ferromagnetic core.